It is May 5th and it is Tuesday, and math this week and next week are going to be a little bit of a review of some things that we have already learned, but we are going to do a little bit of reteaching just to get your minds back into how to do these problems. We again are preparing you for fourth grade next year and being able to do those problems that they are expecting you to already be able to do. So you are going to have a Think Central assignment today that goes back and does some of these things. We're going to be doing some work that you can't do directly in your workbook. So you are going to need some scratch paper and a pencil. If you do not have that yet, then you should go get that and pause me. Okay, so I'm going to assume that you have some scratch paper and a pencil. So the first learning target is that we are going to solve word problems, and we're going to be able to do that with multiplication and division. So you do not have this problem or this page in your workbook. This is actually page 91 from beginning of the year. We're just again doing some review and talking about how we know if it's multiplication or division, and how to use a multiplication chart and the relationship between multiplication and division. So I'm going to start with this problem here. Again, we're going to talk about do we know if it's multiplication, do we know if it's division, and how would we come up with that answer. So number 2, I'm going to skip to number 2. It says Leslie gave 72 balloons to children at the fair. After the fair, she had 9 balloons left. How many balloons did Leslie start with? So if you think about this problem, we are going to think about what kind of problem this might be. So it says Leslie gave 72 balloons to children at the fair. After the fair, she had 9 balloons left. How many balloons did Leslie start with? So if I just took these numbers and said 72 balloons and 9 balloons, I would probably say, hey, wait a minute. 72 divided by 9, except for, is that what they're doing? Are they dividing these balloons amongst children? Actually, no, they're giving away the balloons. So if we had, so here we go, we had 72, and we gave away 72, and now we have 9. So we could draw a picture of 72, that's a lot. And then we have 9 left. So this is actually an addition problem. So we are going to add 9 because here's what they have left and here's what they gave away. They want to know how many they started with. All right, so in this case, we could look at just 2 numbers and just try to shove them together. But this one isn't division. This one is actually an addition problem. 72 plus 9. I'm going to take my 72, my 9, do it up and down. 2 plus 9 is 1. 1 plus another 1, 81. Equals 81 balloons. All right. So, again, we're just reviewing how do we solve the word problems, how do we make sense of the problem, right? All right. Tony hung some photographs on the one wall of his room. He hung them in 3 rows with 4 photos in each row. How many photos did Tony hang? And so we could draw a picture of that. We could draw 3 rows and their pictures, so I could make them into nice 1, 2, 3 rows, and each row had 4 photos. So that's 1 photo. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Do you guys remember what that's called? That's called an array. We use array when we're doing multiplication. So we have 3 rows times, how many are in each row? 4 equals 12. 12 what? 12 photos. So you guys remember, anytime we're doing any sort of problems, our success criteria are, did we draw a picture if we could? Did we make sense of the problem? Did we write our equation correctly, and are we tending to precision? Is the answer correct? 3 groups of 4 is 12. All right, let's skip to, say this one. 60 students are in the marching band. There are 10 rows of students. How many students are in each row? So we can do what we used to call a fast array. And a fast array had so we didn't have to draw all of them, but we had 10 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can draw 10, and then we know that there were 60 kiddos. There's 10, 60 here, and then if you remember, this is the part that we're looking for. What is that? Right there. So 60 total. We don't have to draw them all. You could, though, if you were trying to figure out your problem. So if we know the big number, and we're trying to figure out what times 10 equals, so we could write that 10 times, and then I could use, let's see, their students, but an S is hard to, okay, so I'm going to write an N. All right, so 10 times N equals 60. Well, the other way we could work that out is 60 divided by 10 equals N. And then N equals. So we have to use our division skills, my friends. 60 divided by 10. When we have tens, you know, that we can focus on, we can ignore those zeros for a little bit. 6 divided by 1, 6, and then we have those zeros. So 10 times 6 equals 60. So N equals 6. 6 what? 6 students. So this number here would be 6. All right, so again, so we've done an addition problem, a multiplication problem, another multiplication problem that was actually a division problem because we had the big number there. Now don't forget that sometimes they don't write the numbers. If you just see 10 and go, I don't know how to figure it out, you got to read the problem, friends. Got to read it. All right, next one. There are 9 players on a baseball team. There are 6 teams in the league. How many baseball players are in the league? So 9 players on a team. So we could draw that. We could make a picture. We could make groups. We could say 6 teams. So there's 6 teams. 1, 2, 3, 4, 5, 6, 6. And there's 9, 9, 9, 9 on each team. That's could be our picture right there. We could also, but we know that's 9 times 6. 6 groups of 9. And let's remember, we could use our 9s trick. So if we put our hands out, and we know anything times 9, so we always start on the left. 1, 2, 3, 4, 5, 6. Put that finger down. Then we look at how many are over here on this side of that line. This is like a line dividing, wall dividing. So there's 50. 1, 2, 3, 4, 5. That's our 10s. And then here's our wall. 1, 2, 3, 4. 54. 54 players. Hopefully some of you still remember your multiplication facts. Really hoping. All right, we're going to keep working here. So you're going to have a puzzle penguin problem today, my friends. And again, you're trying to think about what puzzle penguin did wrong and be able to explain what he did wrong. So it says, today I found the unknown number in this division equation by using a related multiplication. Is my calculation correct? 30 divided by 5 equals what? 7 times 5 equals 30. If not, please correct my work and tell me what I did wrong. How do you know my answer is wrong? Your friend, Puzzled Penguin. All right, so we're going to take a look at here. What did Puzzled Penguin do? So we know that when we have that multiplication and division are inverse operations. They're, the opposite. So whatever number goes here should be the same number times 5 to get 30. So we could multiply, we could count by 5s until we got to 30 to find our answer. So let's see if it's 7. 5, 10, 15, 20, 25, 30. Uh-oh, that's only 6 fingers. All right, so is Puzzle Penguin correct? No. You should have multiplied 5 by 6 to get 30. Then you could do 30 divided by 5 equals 6. Okay. All right, so you're going to have a similar problem to that has to do with inverse operations. So we're going to kind of just look at this section here. 30 divided by 6 equals blank, so we're trying to figure out what times 6 equals 36. So included in our stuff here, you're going to find, I bet you forgot all about that, multiplication table. Here are all of our numbers, 12 times 12. And just like on our name tag that you don't have at home. So we are going to, you've got this to use. So 36 divided by 6. So remember when we're doing division, we're really looking for multiplication. So we said something times 6 equals 36. So here's our division problem, and then we know that the inverse operation is something times 6 equals 36 when we're looking for the division. So I'm going to find 6 across the top. There's 6. And then I'm going to look down 6 because I need to know where here is my answer. So I'm going to find 6 and I'm going to look until I get to the 36. Bingo! Here's 36. And then I'm going to look over to here, and that's also 6. So 6 times 6 equals 36. So I could put that here, and that same number is going to go here. All right, the next one is 45 divided by 9 equals what? Well, what times 9 equals 45? Now, remember, these should be review. You should really know the answer to these, my friends. But in case you've forgotten, you do have this multiplication chart. So we're looking for 45, and we know the number 9. So I'm going to come over here to number 9. I could also come down here to number 9. Either way is fine. Start with my 9 across the top. I'm going to count down until I get to 45. I find 45, and I'm going to go zoop, and there's 5. So 45 divided by 9 equals, or 5 times 9 equals 45. So then that's the same in the division. 45 divided by 9 equals 9. All right, hopefully you should also remember how to do these on your own. 10 divided by 2 equals blank. Blank times 2 equals 10. So we go 2, 4, 6, 8, 10. I counted by 5 fingers. That one I don't really need the division. I don't need the multiplication table for. 42 divided by 7. Ooh, that one's a little harder. Some of us didn't get to our 7s. So if you did, then you should remember it. If you don't, then you can find your 7. Go down to 42. Work your way over. There's our 6. So if 6 times 7 equals 42, then 42 divided by 7 equals 6. One last one, 64 divided by 8. What times 8 equals 64? I seem to remember Mrs. Harrison had a really great way to remember this one. I ate and I ate till I was sick on the floor. 8 times 8 equals 64. Here's my 8. And since multiplication and division are related, you can use anything on the multiplication table to help us with the division problems. All right, my friends, you are going to go to the lesson on Think Central that says Review Lesson May 5th. And you are going to go through the problems on that, and I will get your score from there. So good luck, and really work on those multiplication problems.